I'll turn things over to Dave to start talking with us about, I think, plans for hopefully putting together a paper in the very near future here on some kind of the version 1.0 of trying to propose some standards and means of ensuring data compatibility between different game data tools in sort of the open game data ecosystem. So with that in mind, let's go ahead and get started. So again, this is part of the open game data community, an NSF-funded research incubator, just trying to bring people together to improve the state of educational game data research. The goals of collecting resources on the best practices in game data analysis and general database methods within games, as well as to build infrastructure to support research in educational games based on ideas of openness and sharing and repeatability and flexibility and all kinds of great open science stuff. So on that topic of resources, of course, we have the Open Game Data website linked here in the slides, opengamedata.fielddataLab.wisc.edu, all of our data, as well as links to the games, game source, documentation on game data. All of those things are available through that website. We've also got a Slack community for anyone who is not a part of that yet. We will add that to the chat here as soon as I finish my little spiel. Great place to sort of discuss ideas, thoughts, projects that you might be working on, ideas that you have for a future iteration of these office hour times, maybe something that you'd be interested in presenting or talking about. And then, of course, there is the office hour sessions like we're doing today, where we try to give working examples of in-progress game data research, collect and give feedback on projects that people are working on, and help other members of the community keep their work moving forward. And so we've got a link for that as well. So a brief overview of how the sessions themselves work. They're modeled on a series that the Stats Ed research group did at Carnegie Mellon for a while, that were designed to help students get feedback on their projects with faculty and statistics. And so building on kind of that model, plan is we'll spend 10 to 15 minutes here with, in this case, Dave presenting a little bit of context on a project that he's thinking about. And then the remainder of the session we'll spend as a community just sort of discussing the project, understanding the underlying goals, and giving feedback and suggestions on sort of next steps and things to try. We record these sessions and add them to a library. I think, is it on a YouTube page, I think, Dave?
Yep.
Yeah, and so we hold on to those as sort of a library of another resource to help people understand how game data researchers think about problems in analysis and generally how to perform good research on game data. So a couple things to keep in mind. As always, these are work in progress, public presentations of work in progress, so that can be a little bit intimidating. We always want to be keeping in mind that it takes a certain level of bravery to even want to talk about a work in progress thing in front of a bunch of people. So we just want to be, considerate and positive, and to expect that any ideas are potentially going to be a little rough, maybe not fully developed. This is a workshop time more so than a presentation time. The ultimate goal is to help the presenter understand and then achieve their goals in their research. And ideally, these sessions will help with learning for everyone who's involved. So if a concept gets brought up that you're not familiar with, feel free to ask questions or clarification on unfamiliar terms, unfamiliar ideas. And if you've got suggestions to make, again, feel free to raise your hand and provide suggestions. And with all of that in mind, we'll hand this off to Dave to get us started on today's topic.
That's great. It's funny that we go through that every week, but I think it's so good to keep just like the focus of this, and then also for the video recordings, just to make it really clear, like what we're trying to achieve here. So let me share. Today is going to be very work in progress compared to the last couple sessions we've had that were, very kind of thought out. I think we're in just a different space with this one. I really need everybody's help today. And I've got a couple like this actually coming. And it's kind of where we started, where we had a group of people that would get together and just workshop through stuff we were thinking about, and it was really helpful. So today is going to feel like that. It's definitely a working meeting. So the high level like thing that's happening here is that I've been really inspired by the last couple sessions that we've had, and I've wanted to move the idea forward around just how we could create some standards and ways of collaborating. And then it was a little bit of a surprise. I wasn't thinking about it, but there's a conference that's coming up, the IEEE conference on games. And they've got a submission deadline that's here just in a few days. And I thought, let's do it. I think we should give it a shot. So really high level goals for today is, I probably should have been clear here too. Like we've got this paper that we might shoot for. And I'd love to get into that, but it's like, I really want to make this process open and keep us all talking about how we're thinking, because especially a paper like this, we're really looking for input. Like, is this going to work for all the games? And that's what we're trying to get. Is this going to work for all the researchers? So the not so secret goal here is that we're trying to just make our own research and processes really public. And hopefully what that's going to do is create some investment and buy-in from all of you that you're going to start liking these ideas and wanting to invest in them. And together we're going to end up building a community. So what I wanted to do is anybody from this meeting that gives feedback and is invested in this idea going forward, I want to make us all co-authors on this next paper, because I would rather be putting in papers that have a lead and maybe many authors than closed off designs that are happening between just one or two people. So I'd love for us to start coming out of these meetings with 10 author papers where we're saying, yeah, a bunch of people really thought about this. And especially for younger researchers too, which I consider myself one, it's great just to be part of the process of like cranking out more papers and thinking them through and critiquing them. So we want to describe some of the initial papers we've done and then set the stage for this new IEEE conference on games paper. Maybe we'll get around to some of the next ones that have to come. So very practically, what that's going to mean is that I would love it for us to dig into some of the high-level concepts that we've got for this current paper, because I know there's holes, I know there's problems with it, and I'd love to capture some of the bigger ones, at least know what some of them are before submitting this thing. So let's start here, like within the trajectory. The first paper we put out on open game data was, just a couple months ago, really. And it was for the joint conference in serious games. So Luke and myself and Sarah presented this paper out in Ireland, and it really was designed just to be kind of our first citable paper. We needed a way to cite this thing, just to put something down. So the focus of it really was on open science and what open science is and how that creates a real opportunity for education games research and games research generally. And then it provided some examples of how this kind of approach of data mining and game data research, like what are some of the things we could do educationally with it. So that paper we've put out, and it it's short, it's simple, and it really makes a case for open science. The paper that Luke just submitted This one went to the Learning at Scale conference that I know Manuel has submitted. Yeah, like you've got that one published through them.
Yeah.
I don't know if others have too. So this one was kind of in response to the one that Manuel led. And the idea here was let's lean a little bit more into the idea of scalability and some of the kind of technical requirements that get us there to work with really large data sets. Luke, am I doing this paper justice?
Yeah, yeah, so,
So hopefully we'll get that one through. But it really kind of moved into like, what does it mean to do this big? What is this to do it with a lot of people, with a lot of approaches, with a lot of data? So it moves in that direction. Okay, so the one we're talking about today is really trying to go into a little bit more on the can we create some standards and can we create some conventions in our community that help us work together? So the high level idea here is that we're not the first people to try this. You know, there's people that have created big tools. There's people that have created big data repositories. There's people that have created data standards. But I would suggest we're not satisfied. Like we're not done here. There's more work to be done. And we really want to defend this idea to IEEE. I mean, these are standards people, right? So the thing that we want to kind of get at here is that it might not be technically innovative. It actually might be that what we're proposing or what we're trying to do, you know, isn't even that technically advanced, but it's very common sense and has a pathway towards adoption, right? So we want to make a case for usability, feasibility, adoption, usefulness, not we came up with some clever new way to store data or compress it or something. And then the real goal of this thing is to figure out what the minimum is, like the minimum viable product that we can put out now that will unlock more collaboration than we currently see. So I was really, you know, inspired by seeing like Jimmy's presentation on January with his inspect system, because we've built similar systems and his was better. You know, it was just more thoughtful. It had more components to it. And what was interesting about it is it looked like it might work with our data, right? So that's a huge win. We've got other visualization tools we're working on, and we're hoping that they'll work across games and be shareable. And then with the other place that we need a minimum amount of structure is that we have a bunch of incoming games and the constant invitation to have people share their games and their tools, you know, among this community. So what are the minimum things that we can put in place that will allow more collaboration than we have? So, okay, this paper then is going to start with kind of what's been done, and we're going to move into what use cases we're doing. And for a bunch of these questions, what I'm hoping to do is quickly introduce like where we're currently at with the paper and then get your feedback. And then we'll move to the next question. Just kind of quickly explain where we're at and then get your feedback. What are we missing? What's wrong with how we're thinking? So we'll go kind of back and forth for, you know, the next, 30 minutes or so here. Just having you critique each part of it. So again, very work in progress. Right there, any high-level comments about any responses to what I'm saying right now?
I had a question that might be naive, but have you all looked at some of the other large, like open science frameworks for what I'm thinking of in particular is there's a COBIDAS or something like that for neuroimaging MRI data. And just with thinking through like that might be a good model to use if we haven't looked at something like that, but I'm sort of new to this team, so maybe y'all have gone there already.
No, that's a great comment right out of the gate. Like what communities are we modeling ourselves after? And no, I would say I personally am pretty naive, outside of the fact that I know there are many scientific data repositories that exist, and I've putzed around on some of them. But I would say the main one that is kind of closest to home has been Data Shop. I think that really kind of has served as the pillar data community data repository that's open. That's probably been the closest one. So maybe let's like turn that around and say, Jesse, thanks for even bringing that up. And outside of human brain mapping, which I think is going to pop up, I'd be curious if you have any others that you feel like we should be looking at.
That's just the first one that came to mind because that was something I worked on as a graduate student, was getting an MRI data set prepared. And I really liked their approach and guidelines for how to standardize some of the neuroimaging data, like that's a neuroimaging data or big data, right? And like trying to get everything in the same sort of naming space for how you're tracking events and experimental design and things like that. So they already have a lot of those pieces thought out. And I don't know that we take the same approach to any of that, but just the same, like the structure might be helpful, I think. And just as you were talking, it reminded me of this effort from probably like 10 years ago or something now at this point. But yeah, I always like to copy models that I've seen from someone else doing this.
Yeah, totally. Like, and I know, or here's another assumption I think we have is that, or that I have, is that educational research is a little late to the party, and that other forms of science have been doing and thinking about open science for longer, for a whole set of reasons. Yeah, that's great. So those are Data Shop, I would say, is the main one we've looked at, and then Adage was done. It really was here at UW-Madison and MIT, and this was an effort led by the Games Learning and Society group. That was when I was, a graduate student the first time. That was something that they were trying to build, kind of as an internal tool that they were trying to share. And it did a lot of this work, but it never really got off the ground. It doesn't exist at this point for games. And then I know the other ones that we've looked at are like SCORM and XAPI are standards for learning data generally, that obviously I'm very aware of. And I would say the big critiques of those is that they're very verbose, and they're really big conventions to jump into, which is problematic for games. And at the same time, they feel heavy to implement, meaning you really have to be thinking about them and invest a lot of time into them. But what they do unlock is interoperability between tools. And then the new one that Erik's found is XVGM, which I don't know much about at all, but XAPI-SG for serious games is one that we were just talking about before the call kicked off, realizing that that shows a lot of promise as a well-defined standard that might end up being a good export for us, like a connector to other tools. But apparently, even in their own paper, they talk about how it's not a good format for telemetry because it's just too bloated. It's just too much data to be sending across the line. But it might be a good file format for us to play with. So I'm kind of curious if folks have more bigger projects that we should be thinking about front and center. Yeah, go for it.
It's not so much a project, but my interest is that we are building our processes for the Center for Transformational Play at Carnegie Mellon, where because we're a brand new center and we've only existed for a year, we have a lot of space to introduce processes and tools for making sure that what we are working on is broadly accessible and invites collaboration and doesn't end up shut off in a vault where nobody can get to it because of decisions that are made in the either the research and study design process or during making our technical decisions. And so I guess my bigger project is very specifically the broader center processes so that whatever we end up doing sits at least adjacent to this project, if not right in the middle of it.
Yeah. Yeah, I think that's where the data pipeline stuff starts to come in too, where you're like, what are the main parts that exist? Well, cool. With that in mind, then let's like mosey on and try to get there pretty quick. Okay, use cases. Here's another big one, and this one, even some of your stuff is going to factor into this. So this set of data to inform design, research, teaching, and the player has been the closest thing to like an overarching framework that so far has captured pretty much everything that's come up for me. So let me talk through a couple of these and then get your response to it. So informing design is probably the simplest one to talk about because I think that's just game analytics, has the same goal. So for us, for example, we ran large-scale experiments around one of our games, Joe Wilder, to test out different, forms of the script and saw what effect that had on likability of the player, interest in history, a whole bunch of stuff. So large distributed A/B tests. In this case, it was a 4-condition test. We've done that kind of stuff. We've certainly have done lots of analysis around where people get stuck in the game and go look at that. Battleship Numberline is one that I bring up because there's an excellent paper called The Rise of the Super Experiment by Stamper and Lomas and some others, where they run, like 40 conditions or something on this little game and scale it to tens of thousands of students. So that's the package of A/B testing, game analytics, learning, data to inform design. We want to enable that. On the research side, the big things that come up are a little different. They go beyond analytics and they start requiring much more detailed descriptions of what people are doing. So the project that I'm just calling Quick Red Fox is actually a platform that Ryan Baker and Luc Paquette and some others have worked on that gives researchers a real-time event while gameplay is happening. So researchers in a classroom will get an iPad that'll ping, and then it says, hey, something's happening interesting with player 13, go interview them now. So it becomes a tool for qualitative researchers to get real-time indications of phenomenon they might want to focus on, right? So this is a project that we've got some proposals in that are doing other versions of this as well, but it's real-time detectors. And I think you'll see in all 3 of these, it's using big data to inform qualitative work, or at least playing with qualitative ways of thinking that are being augmented by machines and data. So replay is a similar idea, right? So Elizabeth Rowe, as well as, again, Ryan Baker comes up. Our project recently with them and Stefan Slater, where both video replay and text replay of games are, brought to the front, allow qualitative researchers to go and code the events that happen in it and find patterns through qualitative research discovery. So this is like a use case we definitely want to support and keep working with. Anecdote, we just had a VR replay tool that we got working, and I had like a visceral reaction to seeing it work because VR research has been so hard to do because you can't see what they see the same way. Even, and getting it mirrored onto a screen is it's cool, but to be able to just see some kid out on the internet like played VR, but this is how they moved at, you know, high frame rate. It felt like a usability study breakthrough. You know, it was like, we are finally going to figure out why people are getting stuck or why these things are hard. So I'm really excited about replay. And then last one I'll mention is epistemic network analysis. So, you know, this is like when you're, you know, combining talk events with, you know, gameplay events, and Jennifer Sienna and others have used that method. When we talk about data to inform teaching, you know, the couple of things that come to mind are like what Luke has been piloting and dissertating on with dashboards that give teachers real-time insights. But then also like what Ken Holstein did with the HoloLens, where he had like real-time augmented dashboards sprinkled throughout the classroom, like above kids in physical space, reporting on what they were, you know, doing and where they were struggling and all of that. So I think the key thing here is like it's real time, and it's thinking about display to teachers so that they can do something. And then Maggie, who, you know, is obviously a collaborator on this project, constantly talks about data to inform players with what they're doing. But I this is where I'm like totally drawing a blank. I don't really know any projects here. So again, here's some of the things I know. I didn't try to explain everything I know there, but are there big areas that you're noticing like, oh, we should be thinking about that use case? It's falling outside of this framework.
So the one response I'd maybe offer here, not even that I have like a use case that I see missing, but like the slide here is labeled, you know, what use cases are we trying to facilitate? But then the organization of the information on the slide is really by stakeholder in a way.
Huh.
Right? So I would argue that the quick red fox, you know, a real-time in the classroom ping for a researcher is a lot more closely related as a use case to something like a teacher dashboard than it is to ENA or replay or things like that. So it might be worth, when it comes to thinking through use cases, to think about it in that way. You know, identify the stakeholders, but then within that, when we want to talk about use cases, what we really want to talk about is identifying those categories of the uses of the data, how they're being used, more so than, you know, thinking about it in terms of who it is that's using them.
And if I hear you correctly, Luke, the thing that you would have focused on there would be real time.
No, that's just an example here of something that I see as sort of properly a use case or a category of use cases.
Yeah.
So I think that looking at it from like, I'm not trying to say that anything was wrong here, because I think that thinking first of who are the stakeholders and using that to help identify use cases is useful. But my suggestion here is that if we try to think of and label use cases by, you know, what are the common uses, not necessarily what are the groups of people that would use it, that might help us identify use cases that we wouldn't otherwise.
Can you give me an
recognize.
example?
So rather than talking about this in terms of like designers, researchers, teachers, we might talk about, let's say, analysis of a specific group of users. That might be something that happens to inform design. That might be something that happens to inform research. It might inform teaching, right? But it is one slightly more scoped use case. Use the data to analyze a specific group of users. Another use case might be use data to help with like to identify learning outcomes, or it might be using data to give real-time feedback on gameplay, or it might be let's see, use data to to identify affect. I know that's another one that's been brought up. And so just when it comes down to let's identify use cases, my suggestion here really is just let's frame that in terms of, organized by category of use case, more so than organized by who are the groups of users.
Yeah, that's good. Cool. Before moving on, I'm curious if anybody else has any, have you thought about this thing over here? Game data is really cool with that thing. Doesn't seem like it's fitting in here.
I just to say I think this fits in with and covers a lot of the use cases that we at PBS have encountered so far. And I also agree with the idea of focusing on that use case of what are the requirements if data is to be analyzed in real time versus en masse later. And what are the requirements if you're doing, player related, what am I trying to say? Like closed loop adaptivity versus, a straight gameplay where the levels are already set, or on the fly, like A/B adjustment assignment type of thing.
Yeah, good.
I think that could be helpful.
Yeah, that was not in here, even though, yeah, good. Even though we're doing it. Yeah, that's great.
I don't know how well this fits into use cases, but I know one thing we haven't spent a lot of time thinking about is sort of multimodal data and things other than telemetry data that might be collected.
Yeah.
I think the furthest we've gotten away from pure game data is questionnaire data, like pre-test, post-test external measures.
Yeah.
I don't think that we've really thought more deeply about other kinds of data that might be collected and aligned with gameplay.
Gesture is the closest thing that we've been involved in.
Yeah.
Yeah, that's good though. Beyond surveys and gesture. I think that's the future of this, right? We want to be designing so that if a researcher wanted to put a heart monitor on someone while they're playing, they could, and it would work. We haven't blocked ourselves from doing that. Yeah.
I just want to add a yes and, which is that one of the teams that is with CTP is specifically working on streaming. And
Yeah.
so mapping on-screen action to reactions in the chat are a big part of what they're thinking about. And
Yeah.
so that is something that I'm regularly knee deep in wrestling with. How do we document that? What is the coding process? How does that tie back into the conclusions the team is reaching?
Yeah, that's good.
I could certainly imagine when we talk about sort of affect detection, there might be video stream, biometrics like you've put in there, other aspects of a player's physical behavior that might be interesting.
I have a question, which is so far is most of what the thinking around digital games rather than analog experiences?
1000%.
Okay.
Yeah, in my mind, the wall is so heavy. It's just like the kinds of things you need in the digital world versus not.
Sure.
Yeah, it's just such a, yep. Games aren't the game data is the unifying thing. Where, yeah, it's got to be a certain kind of data. It's going to be game-like data, and it's got to be digital. Yeah. I love board games and everything. I'm just saying for this project.
Absolutely.
I mean, there are things where some of our research partners have set up physical contraptions to emit telemetry. So like
Getting closer.
that's sort of a blend of them. I don't know if that.
That
But to
would be
that end, I
another
think
whole
it.
fun talk of like the affordances of game versus analog gameplay and all the sensor devices you can do in the middle with cameras and computer vision and all that.
Yeah, I think maybe the distinguishing factor here is that a lot of what we think about centers around capturing telemetry, not just of what the player is doing, but also being able to tap in directly to sort of the game state via the system of the game that is
simulated
purely
universe.
digital. So I think maybe that's where part of the dividing line happens, where if you've got a physical experience that's capturing some telemetry, that's something that I think would fit as a potential case for multimodal data. But I think for the core game data project, one of those necessary things is being able to actually have access in your telemetry to what was the state of the game and what were the responses of the game system. That at least to this point has been a pretty important, if sometimes hidden or implicit, key point of our thinking.
Yeah, that's good. I don't know. This is okay. So this is a little bit of again, thank you for helping with the scoping stuff, right? It's like, what are we trying to do and why? It's really important. But I think this is starting to converge a little bit and say, okay, what is the manifesto for this project then? And we're getting closer to the, what do we want? And this is starting to make us go down a certain path. So I think these are pretty self-explanatory, but this idea of data should describe the game experience. My assumption here is making games is so freaking hard already. The last thing we need is data people in the room making it harder. Let us make our game, figure it out afterward. That's like one of the values I think here is that like games are coming from artists, and it's the job of the data people to figure it out afterward. So that's like a premise. And then right along with that is just to be as lightweight as possible. Like if there is a game that is already trying to get every frame per second out of the hardware it's on, the data stuff cannot break it. It's back into the like data should follow design, kind of attitude, right? Maybe that's a better phrase here. Yeah, that's it. Okay. So then the other one was like, let's build stuff that's not for experts, like the people that already know how to work with XAPI, SG. They don't need our help. They're just going to do whatever they're going to do anyway. So they're good. They're super good. They don't need our help. So how can we unlock people and processes that are just more general purpose? So for example, when we tried to export JSON data, no one could work with it. Like, and by no one, again, I mean, really smart graduate students couldn't work with it. As soon as we put it out as a tab delimited file, it's like, got it. I got it in Python. I got it in Excel. I got it in RapidMiner. Just works. So I feel like that's been one of the things you'll see as we focus on like file formats that you can just look at and not have to be a programmer. The other thing here is this came out of a conversation with Ryan Baker recently where he was comparing Data Shop with Morph, one of the platforms they made for like online learning platforms. And he was saying Data Shop really got it right, that they just made the data available and you just download it and you do whatever you want with it using whatever tools you use, where that's what people really need is like, so apparently the parts of Data Shop that are used less and what Morph does a lot of is these big tools that allow you to like analyze everything and figure it all out. And, so you got researchers that are building tools to do all the analyses they can imagine. So I think the attitude here is, let's just get data out of this thing as quickly as possible and let people play with it using their own tools as easily as possible. And then we're kind of always responding to that and trying to capture any innovations or generalizations, but really assume a pretty wild ecosystem, right? Like not big monolithic tools. Then there's this other one that we've been talking with Erik Harpstead a lot, which is that there is, across the different previous projects, there are a lot of different decisions that are made around what data is even captured. So, you know, if you talk with hardcore evidence-centered design people, they're going to say, you know, figure out exactly what you need the system to provide you with and only capture that. And that's one fork in the road. And then I think with the other fork in the road is around, well, we've seen projects that they send the results of analysis, not the raw data. So the game is actually doing all the logic inside the game and sending out like what the results of models are and things. So I think the idea here is, how do we record as much data as simply as possible so that we can come up with analysis methods downstream at a later date that we're not even aware of now. So this I'm starting to call this record first, analyze second. So as a value, get the data. We don't even know how we're going to use it yet, but if we get the right data, we'll be able to replay it. We'll be able to reconstruct the whole scene. We'll be able to second analysis. The other one is just expose intermediate work. My catchphrase for this is, I should be careful about this because Stefan's brilliant. So working with world-class data scientists, specifically Stefan Slater out at Ryan Baker's lab. And there's a huge difference between a Python Jupyter notebook that's on his desktop, like this one hidden place, you know, in there, versus like, how do we expose every step of the process and all the intermediate work objects so that anybody can analyze them, critique them, you know? So I feel like so much data science happens that way. It's like the artist goes into their cave and emerges with their findings. And we're like, nope, I want everything exposed. Like every line of code, every intermediate data file that you use. If you filter something, I want to see it. If you move it to, you know. So I think it's exposing all the intermediate work. And that's kind of really close to making the process, I'd say code / transformations. So same thing there. It's like, not only do I want to see the work product, but I want to see the code that converted one thing into the next thing, and be able to inspect it. I found this word recently that describes these things as functional data processing. So the idea here is like that it's immutable data and repeatable. So you should always have like these immutable files, and you can put them into a process and you'll always get the next one. And the pipeline is therefore completely exposed. So those end up being kind of some of the values, I think, going into this thing. I don't know, these are going to emerge. So I don't know if it's worth like talking about it in detail here, unless something's like really popping up. If not, the next slide is the one I'm probably most excited about. So tell me if you have any other manifesto issues. Okay, so high level, here's the process that we are submitting. So the idea here is that we break all the steps out that a normal data science process would follow. And each one operates kind of in its own little process pipeline. And the idea is that, roughly speaking, you move through the stages of this pipeline almost always in the same direction, except for this one little loop. And at every stage of the pipeline, we're spitting out files. And what that means is a tool can be developed to work at any one of these output levels and should be able to work across games at any one of those output levels. So a tool that's created, and some of these even blur together a little bit, like sessions and players a little bit, but you should be able to hook like a viz tool, for example, on at the player level It should just take this file input. It shouldn't need an API. It shouldn't hook into anything deep. It should just go to a website, download a file, and the tool should be able to load it and be able to make whatever assumptions it needs. You know, you can like configuration options to make that work. So practically what this means is that we have from games, we've got a raw telemetry format that goes, it's just captured into a logger. So this just stores stuff. It's in a really raw format. And the key is that it's time sequence. So it's this happened, then this happened, then this happened, then this happened. That's each row. That gets fed into detectors, which also output time sequenced events. So this happened, and this happened, and this happened. And that means now you should go talk to player 13. Or that means now we think you're idle. But it's all of those time sequence assumptions that are calculated and not generated by the game itself. From there, we make the move into stuff that is not time sequenced anymore. It's aggregated. So our most fundamental unit that we see are sessions. So across a session, what are the features that describe the session? That code sits on its own. It folds up to multiple sessions are together and grouped by players. If we have that information, sometimes we don't, sometimes we do, but then we can talk about, well, how did the player perform across sessions and how many sessions did they have? And how do we think about the player? Populations kind of follow suit. They're saying, how do all the players wrap together and how do we describe groups of players? So you pick certain players and you group them together and you say, what are the features that describe this group of players versus this other group of players? Second order features got brought up again because of Manuel and Jose with YJ's project, where they had these features that were, what were they called? Not histogram, but percentile features. So it was this player is in the top 5 percentile of how fast you complete a level. And it just totally broke all of our logic because that one requires you to have analyzed a population and then look at a session or a player in light of population features. So this is the one that goes backward. And so these second order features basically rerun player features or session features based on what we've learned from populations. And we realize that this in the pipeline is the same stage, I think, as where models would enter in. So these are models can be anything from player taxonomies. So they're part of player group A, but they needed all the population, they needed all the data to figure out that group. So we built a model and put it into this stage of the pipeline. Or it could be a prediction is where a model would run. Given what we know about this player, we expect them to never return and never have another session, or we expect them to do this in their next session. And then the last one we've got in here is model evaluations. So this is like, we've got these models, they've been made into code, they're running on production data. And then as new data is coming in, we continue to evaluate them. How good are they performing in these different ways? And they're exporting a file as well. So now we're getting into the thick of this and saying like, I think these are the stages. We've built most of these already. We've built everything except for models, but we've built second order, but we haven't really used them much. So now we're getting close on time and I knew eventually we would run out, but respond to this. Like, are there obvious problems with this? Are there obvious games this won't work for, or obvious research processes this won't work for?
Dave, I was curious, so with the modeling step, which is new here, there's a lot of general purpose in the features and the event data, but do the models themselves not more have specificity in purpose and application depending on the research question, the research project, different assumptions there that would require more customization maybe than just a general purpose TSV export like we have available currently for future data? Like if we're building out some kind of regression, some kind of predictive model, the assumptions and the data that we're using and the steps that we're taking there change for every application, right?
Totally, yeah. Maybe to clarify that, because you know, we've built models together now.
Yeah.
So the way that I would imagine that is that a modeler, so a data scientist in your role, would grab a file, probably like players or populations or both, and you'd take those files and you'd go off into the cave of Python and you'd go run a bunch of analysis and come up with a model. And you would then even report it back in a meeting, and we'd say like, hey, we got our AUC up to this, and these are the features that we ended up actually using out of all these features that are available. And okay, so all that would happen separate from this pipeline. You'd be here on this pipeline, you'd be outside of it. But then if we get a model that's good from that, then we cook it into the infrastructure at this level. So we literally take, like, if you created a linear regression, we would have a linear regression chunk of code that takes all the inputs from the previous data, runs a linear regression, creates an output, and spits that out as a file. So we would have the player with columns added on the end saying it's a type 7 player, or we predicted them to quit, or whatever the model was meant to do, and the output of the model would happen there. So that's different from the training of the model, which you're doing totally outside of the system. Does that make sense, or does that resolve the issue for you, or is it there's still?
Yeah, I think mostly, but I could see some instances, even with projects that we've worked on specifically, where maybe a model mostly fits another application, but there's some fine tuning.
Oh, I don't think models will work across games either.
Yeah, but even specifically within a game. So for example, we just optimized a model for AUC, right? Maybe, and that's just because we wanted to balance between those accuracy metrics, but maybe another group wants to optimize for precision recall or some other metric, but wants the same overall model. So I can see where you could want some customizability without starting from scratch.
Yeah, totally. Yeah, there's another assumption that's in the middle of that here too, which is that the actual file formats between these, like the vocabulary, this is why I was really kind of excited about seeing some of the people that are here. The only one that we have any definition around is this. Like it's a pretty loose definition. And then when it comes into the vocabulary of like which features are always going to be there, that's like version 0.2. Like I would love to describe some of that and like say like these are the features that are essential for compliance with 0.2. These are the features that are essential for certain tools to plug in at different levels of this. But the assumption right now is that we're not there yet. We're just trying to take this ground. But that's like the next obvious step is like which features can you count on existing, and then which ones are create compliance with different standards. So don't have a slide for this, but starting to think of it as you have the open game data 0.2 overall event compliance, but then you have the VR deterministic replay compliance that allows all those tools to work, meaning certain features are delivered in a certain way, so certain tools are there. And it ends up looking more like a requirements file in Python, where you're like claiming all of the compliances that you've hit so that you can work with different tools. That could be with a model too, where you're like, if you supply me these features, this same modeling code is going to work. And it's up to you to just get those features in that shape. And then again, we can give that a name. So it ends up being that each game and each stage of this ends up being a web of different compliances that not all games will fulfill all of them, well, obviously. But everyone, it gives you like a roadmap of like how to unlock tools.
So with the last minute or two that we have here
Yeah.
of our office hour time, the one thing that I'd like to point to would be, all right, so given this pipeline, I think the pipeline kind of hits all the different points that I would imagine for processing data in sort of finer and finer degrees. And yeah, it's great that at each step, there's sort of some kind of an output that pops out so that anyone, when we talk about like compatibility with tools within an ecosystem, be able to say, yeah, there's an output that kind of pops out at each stage. And when we're thinking about like research projects and data science, I definitely agree with the idea that TSV is a great way to go for interchange. And so being able to define what should the structure of this tabular data look like, right, that just happens to go into a TSV container. When we think about things like dashboards and web-based tools that we've talked about for analysis, like that inspect system, for example, most people probably don't want to run their website by going to a different website, downloading a file and uploading the file to the website they actually want to use. You want to just be able to hook straight into an API, which is a thing that we've gotten into a little bit in some of our own projects. APIs, like the tools for exchanging data on an API doesn't always fit super well with like what works well for a table-based file format. So I think maybe there's a round of thinking that goes into how can we define the shape of the data both for a table-shaped format for files you distribute to people, but also think about how can we make sure that we also have a way of taking the same data and putting it into a shape that's more conducive to an API.
Yeah.
And to sort of have those, in parallel here, here's the specification of what data you need, and here's how that data should be shaped for this kind of output and that kind of output, so that you don't run into a situation where people have to like write weird JavaScript code to read in a bunch of tab delimited things in a way that just, creates headaches.
Yep. That's good. Yeah, I think you're right. The APIs almost are parallel to it. Gosh, I knew we were going to run out of time, and this is not a thing you do in 1 hour. Like that's the wrong unit. So we have to wrap up. But Jesse, when are you on for, let's see, because I really wish we could get into your stuff right away. Oh, you're not on yet.
Yeah, but yeah, I definitely would love to show you all. We've gotten pieces of this pipeline and we haven't explained it so beautifully. But I think like we as a team at PBS Kids have been moving towards a system like this. And so we've built some of the pieces along the way. That being said, it's built for our internal use so far. So we haven't gotten to those pieces of like, saving out these individual files so that other people can pick them up and, input them into other things. But certainly that is needed. So this looks great.
Yeah, I'd love to get you on the calendar to respond with what PBS has built out so far. Because I think in all the interviews I've done so far, PBS is like the one that has some of those same challenges of it's got to work for all the games at scale. Like it's got some of those shapes that are very different than most of the researchers I've talked with. That the more common story there is, yeah, we open up a blank Python file and every project starts from scratch. Like that, or maybe we pull in some like utility functions, but reusability is not the thing. Okay, we've got to wrap up. I am so grateful for input here, and I'm glad I'll get all the comments out of the chat. But so how this is going to go together is like I'm basically just writing this thing hard for the next couple days, and I would love it's going to be too fast for us to do any like serious review, but I think what I'd like to do is probably after I submit the draft of it, I'll send out something, so while it's in review, we can come back to it and talk about it. Maybe Chelsea can present. We can have more thought, and then really we'll be rating, like, if the paper even gets moved forward, then we'll use the camera ready revision to like make changes to it. If it's close enough, and throw on everybody, you know, that's providing comments and stuff as authors, like I mentioned, for that version of it. And if it gets rejected, then this is just a good way to get this process rolling, because we need to write this paper for someone, and get this thing, you know, out in the world and citable and such. So if we do it right, for example, PBS should be able to plug right into this. We should have some like obvious interface moments.
Awesome. Well, thank you everyone for coming in and joining in with all the discussion here. So we've got looking at the schedule there, we've got, you know, several more of these planned out to cover for the next several months. If you've got projects of your own that you are interested in discussing within the group here, definitely feel free to reach out over Slack. Like Dave said, we'll be sometime shortly here, we will be posting the recording as usual. We'll make sure and put up links for everything that was shared in the chat. All of the great resources people have been sharing. And yeah, I don't remember how much else Erik usually says at the end, but thank you all for coming, and we look forward to seeing you all again in future iterations of Office Hours.
Great. See ya.